Hello everyone, we are compt14p2027 and as part of our module, we have extended and developed the Fizzyo game development framework. I, Cosmin, and my teammates Andres and Rio form one of the three main teams at UCL working on Project Fizzyo. Our aim is to provide Professor Eleanor Main and her research teams from the Great Ormond Street Institute of Child Health with the tools to complete their unique trial on cystic fibrosis treatment. In addition, we have been working closely with Microsoft professionals in order to assess our progress and improve our final solution. The goal of the Game Developer Framework is to provide a way for clinicians to assess the impact of gamifying cystic fibrosis physiotherapy treatment. Current treatments involve blowing into a device for long periods of time, which is considered tedious by most patients. The Fizzyo project aims to bring together gaming and Internet of Things concepts to create an engaging experience for the patients by using the devices as controls for video games. This will be achieved through the creation of a Unity package which sends breathing and gaming data during treatment sessions, and through the Fizzyo web portal where the data is displayed. Game developers will have support material in the form of online documentation, a user manual which details how to use all features of the Unity framework, as well as extensive class documentation of the components of the package. The game developer web application provides a direct way of communicating with the server side of the project by means of RESTful API calls to the online Node.js server Fizzyo Cloud. Thus, it will be used by game developers to add and change games and achievements for their games and view game leaderboards, providing an accessible and intuitive way of managing them. This should provide a better experience for integrating games into the Fizzyo framework and ultimately motivate more developers into contributing to cystic fibrosis research. Our solution involves extending the existing Fizzyo web portal and backend server to enable game developers to also use the web application in addition to researchers and patients. This means that we can make use of the already developed systems, which are both tested and secure. Namely, user credentials are not stored in a database, but the authentication is done by receiving a Windows Live token from the auth service and sending it to the API to check if the user is registered. Additionally, user details such as their names are masked with nicknames such as Fizzyo1 in place in order to ensure their anonymity. Our design takes after the existing one in that components in the web application use REST API calls to the server and receive and process JSON objects as responses. This allows developers to add Unity games and achievements to Fizzyo, which can in turn be used inside their games. The Unity framework we completed allows games to accurately measure patient breath data and together with game sessions, achievements or high scores, send them to the API, which can then be evaluated by UCL's teams of researchers. For both the front and extended backend of the game developer web application, we have used Node.js as a runtime environment for building, running, and testing our code, along with the npm package manager. This allowed us to use existing scripts and dependencies, as well as create ours with ease. Furthermore, for the client-side application, we have used the React JavaScript library, in which the legacy portal is written as well. It is an extremely popular choice developed by Facebook, which allows for decoupling the user interface and the logic sides of the application, and comes with a wide variety of built-in components. Albeit complex and with a steep learning curve, it features a lot of quality open source libraries, some of which we have used ourselves, such as React Bootstrap Table. The existing Fizzyo Unity package and our proof of work game have been both developed using Unity as C#. While extending the Fizzyo package, we have not used external resources such as libraries or other people's code apart from what was already in the package. Last but not least, the documentations were built using docfx, a documentation generation tool for APIs and Markdown files. It allowed us for a smooth deployment plan in the already existing virtual machine, where we managed to create the hooks necessary for continuous integration.
In order to register an account, you have to click register and input the invitation code which you have to receive from an administrator. After you have a code and have registered, you can sign in using your Windows Live credentials. On our portal, you can do several things, but primarily you can manage your games. Namely, you can view your games, you can edit your games, you can do things like deleting your games, or you can add games. Alternatively, you can go to your achievements list and perform exactly the same operations, or go to your high scores and view the high scores for your game. In addition, we've also implemented credential caching. So if you were to go to another website and return to the website or simply refresh, your credentials will be remembered. This doesn't only happen for our game developer user, but it also works for administrators or researchers. Additionally, in case the credentials become invalid, the app will signal it to you and try to refresh it itself. To prove it, we can delete our cache, refresh the web page, we'll see an error message, and then attempt to relog, which will end successfully in a new cache, right on the right here.
This is an example of using the Fizzyo device to control a Unity game. So first you breathe into the device to calibrate. And now we're into the game. So the way the game works is we breathe into the device and then we build power, and then Fizzyo device has one button and then you just press it and then you jump according to how much power you've built. So you can try that out now. So once the patient has finished his sessions, he will close down the game, and this will trigger the functions in the Fizzyo framework that post all of the relevant data from the session back to the server. So if we stop playing, we can see that the console in Unity is gonna inform us of what data has been uploaded. If we go into the console, we can see this code that has been posted to the server. We can see when the calibration took place. We can see the amount of breaths, all of the information on breaths, and this also posts any achievements that have been unlocked in the session.
In addition to the game and to the application you have just seen, we have also created a series of documentations for implementing the Fizzyo framework for Unity games, and for documenting the framework itself, where you can see definitions of all available classes and functionality.
In the demo of our solution, we have successfully completed almost all the required features. Both the web portal and the website are fully functional and tested, with extensive and automated documentations in place for the Fizzyo package. Mr. Greg Soll from Microsoft, who was overseeing us in our progress, was also satisfied with our progress after showing him our final deliverables, and along with us, expect the first-year students currently working on games for Fizzyo and any future developers interested in the project to benefit heavily from it. We are happy to have been able to contribute to Project Fizzyo and look forward to the research of Professor Eleanor May to conclude in a cystic fibrosis breakthrough.